Our next section is about acid-base balance. And I find this difficult to explain using the terminology that this book does. I really wish that everyone taking this course had to take some chemistry first. It would really help, but I'll do the best I can. I do like one of their definitions here, but anyway. So electrolytes that release hydrogen ions are acids. And that's a pretty good way of putting it. Electrolyte, again, is something that will dissolve in water and release ions. And if the ion that is released happens to be a hydrogen ion, then that substance is an acid. Now, in chemistry, we talk about three different sets of definitions for acids and bases. And this is most closely aligned with a definition of acid by a Swedish chemist by the name of Arrhenius. There are some acids aren't clearly going to be able to release hydrogen ions, and that sometimes makes things difficult. So there are a couple of other definitions for acid that just take a different perspective, and they can be helpful. But in any event, we'll leave it at that for now, and if I feel the need to show you more as we go through this, I will. Now, substances that release ions that combine with hydrogen ions are called bases. Again, it doesn't cover every possibility, to put it that way. When Arrhenius said that acids release hydrogen ions, he said that bases release hydroxide ions. But that turned out not to be, well, it's not that it's not true or accurate, it's just that it's not obvious. So I like the way they put this here, though. Ions, they don't have to be ions. Substances that combine with hydrogen ions are bases. Anyway, acid-base balance entails regulation of the hydrogen ion concentration of body fluids. And it's important because slight changes in hydrogen ion concentration can alter rates of enzyme-controlled metabolic reactions. It can shift distributions of other ions. It can modify hormone actions. And I think everybody is somewhat familiar with pH. Recall that pH indicates the degree to which a solution is acidic or basic. Another word for basic is alkaline. The more acidic the solution, the lower the pH will be, and vice versa. The internal environment is normally maintained at a pH between 7.35 and 7.45. And that's a pretty narrow range, and it is slightly above 7, so it's slightly on the alkaline or basic side. Now, there are going to be exceptions to this. This is very true for the blood, but like inside your stomach, the pH will be much lower because the stomach produces hydrochloric acid and drops the pH, and that assists in the breakdown of proteins. Anyway, for this purpose here, first we're going to look at the sources of hydrogen ions. In other words, what are the things that are acidic in the body? Most hydrogen ions in body fluids originate as byproducts of metabolic processes, although the digestive tract may directly absorb some hydrogen ions. The major metabolic sources of hydrogen ions include the following. Now, these reactions are reversible, which means they can go from reactant to product and back from product to reactant. But for clarity, they're presented as net reactions only. In other words, they only go forward. Like, here's the reaction arrow, only pointing left or right. But these reactions can go back. That makes them reversible. It is the concentration of the hydrogen ion at equilibrium that determines pH. So the first and one of the major sources of hydrogen ions is that respiration of glucose, aerobic respiration. Hopefully that means something to you. Glycolysis is not aerobic, but it's the first step to getting there. But the Krebs cycle and the electron transport chain, which you should be familiar with from Biology 103. At the end of those processes, you have produced carbon dioxide and water. Now, carbon dioxide and water will react and combine with each other to form H2CO3, which is called carbonic acid. Okay. Now, carbonic acid, because it is an acid, it will ionize, and one of these two hydrogens is going to separate from the rest of the molecule. So we'll have a hydrogen, and then we'll have the rest of the molecule, which is one hydrogen, carbon, three oxygens. But when that hydrogen leaves, it does not take its electron with it. So a hydrogen atom has one positively charged proton in its nucleus in the center, and it has one negatively charged electron that orbits around that. So when this ionization happens, one of the hydrogens turns to the rest of the molecule and says, I'm leaving, and you can keep my electron. Well, when your hydrogen ion doesn't have its negative electron, then the balance of positive protons and negative electrons is upset. And without that negative electron, it becomes positively charged. So it is a positive ion, a cation, and we call it a hydrogen ion. And this is what acids produce. Now, all this, the rest of the molecule, the rest of that acid, after that hydrogen leaves, we call that the conjugate base. And the name of this conjugate base, and this is just something we have to memorize, this is called bicarbonate. Some people call it hydrogen carbonate. The bi in the name bicarbonate does not mean two. We know a lot of words where bi means two. It does not in this case. It's from an ancient prefix. It's a shortened form of a prefix, bis, B-I-S. So I have seen many people in chemistry class get confused by that, and it's understandable. If I ask them what's the formula for bicarbonate, this is what I want to see, HCO3 with a negative charge, they will write C2 because they think, oh, it's two carbons, bicarbon. That's not what it means. Okay, so carbonic acid is formed in your body constantly by the carbon dioxide that your cells are producing and the water that your cells are producing combining into carbonic acid. And then it ionizes to give you hydrogen ions and bicarbonate ions. Now, it doesn't do this to a great extent. It doesn't produce a lot of hydrogen ions, and for that reason, we refer to carbonic acid as a weak acid. Now, a strong acid will completely ionize. Every hydrogen that could possibly come off with a positive charge does. And that's going to be something like hydrochloric acid, which your stomach produces to digest food. There's another strong acid called sulfuric acid, and that's what's in car batteries, and it will burn you badly. Okay, so number one source of hydrogen ions in body fluids is due to aerobic respiration of glucose, where carbon dioxide and water form carbonic acid. The number two means is anaerobic respiration of glucose. And as your body is trying to go through from glycolysis to the Krebs cycle, the glycolysis produces two molecules of something called pyruvic acid or pyruvate, which has 3 carbon atoms in it. And anyway, if there is not enough oxygen present to convert that into acetyl groups, you produce lactic acid. Now, lactic acid, if you're exercising strenuously and your muscles start to burn, the burn is from lactic acid. Third form or third source of hydrogen ions is incomplete oxidation of fatty acids. Incomplete oxidation of fatty acids produces acidic ketone bodies, which will increase hydrogen ion concentration. So I'm sure you've heard of ketosis, and if ketosis goes unchecked, it leads to ketoacidosis, and this can occur during starvation, or it can occur if you are unable to completely oxidize or break down nutrients. So this happens to diabetics. They get into ketosis. It can also happen if you are on a low or zero carb diet, like the Atkins diet. In fact, there's one that's been popular the past few years called a keto diet. It restricts carbohydrate intake, and without some of the byproducts of carbohydrate metabolism, we cannot completely oxidize fatty acids. And I'm sorry if you don't understand what I mean by oxidation and oxidizing it. Again, chemistry would really help answer any questions you have about this. All right, oxidation of amino acids that contain sulfur. 2 of the amino acids, cysteine and methionine, have sulfur atoms in them. And when those are oxidized, it can produce sulfuric acid. And it can't produce much because that's a pretty strong acid. Then there is the hydrolysis of phosphoproteins and nucleic acids, which both contain phosphorus. And when that gets oxidized, it can produce phosphoric acid, and that will release hydrogen ions. Now, phosphoric acid is another weak acid. Phosphoric acid is actually an ingredient in, if I remember correctly, Dr. Pepper and Coca-Cola. Both have phosphoric acid in them. The acids that result from metabolism vary in strength, so their effects on the hydrogen ion concentration will vary. But all of these things lead to hydrogen ions in the internal environment. Now, here they talk about the strengths, and I've already mentioned this a little bit. Acids that ionize more completely produce more hydrogen ions, or strong acids. Those that ionize less completely are weak. Hydrochloric acid in stomach juice is strong. It dissociates or ionizes completely, releases a lot of hydrogen ions. The carbonic acid produced when carbon dioxide reacts with water is weak and dissociates less completely. Now, they're using 2 different terms here almost interchangeably: ionize and dissociate. I won't bore you with the details. They're pretty much the same thing. There is a subtle difference. Dissociate simply, well, okay, salt, sodium chloride. That consists of a positive sodium ion and a negative chloride ion. When it dissolves in water, those two ions separate from each other. That is dissociation. Ionization is when something that is not already made of ions, and hopefully you know the difference between an ionic bond and a covalent bond. So in carbonic acid here, H2CO3, all of those atoms are bonded together with covalent bonds. They are sharing electrons. But when dissolved in water, one of those hydrogens, as I've said before, decides it's going to leave and leaves without its electron. And that means it becomes an ion. So ionization produces ions from something where they didn't already exist. Dissociate is something where there are already ions and they simply separate from each other. Bases release ions like hydroxide. And again, the original definition for acid and base, that's what it said about bases, which can combine with hydrogen ions, thereby lowering their concentration. So if there are hydrogen ions free in your body fluids, they lower the pH. And bases like hydroxide can combine with it and neutralize the acidity. Sodium hydroxide releases hydroxide ions. Sodium bicarbonate, which releases bicarbonate ions, are bases. Now, strong bases dissociate to release more hydroxide than weak bases. So now sodium hydroxide is a strong base. We know sodium hydroxide by the name of lye, L-Y-E. And it is nasty stuff. It will burn you badly. Sodium bicarbonate, on the other hand, is baking soda, and it's a much milder base. It's not nearly as strong. Okay, so often the negative ions themselves are referred to as bases. Bicarbonate, acting as a base, will combine with hydrogen from the strong acid, hydrochloric acid, to form a weak acid. Now, this is about buffers, and I've put a lab exercise in this unit where someone shows how a buffer is formed using, now I don't remember what he used, if it was vinegar and sodium acetate. I think he used carbonated water and sodium and baking soda, which is the same thing I used to do for a demo in lab, and I found that this guy had done it. So you're just going to be watching that video. Hopefully that will be helpful to understanding this. So regulating hydrogen ion concentration, either a shift toward either acid pH, which means going down, or alkaline, where the pH goes up, can threaten the internal environment. Normal metabolic reactions generally produce more acid than base. These reactions include cellular metabolism of glucose, fatty acids, amino acids. We've already seen that list of sources of hydrogen ions. So maintenance of acid-base balance usually eliminates acid. And this is done with three ways. The first being chemical buffers. Second being respiratory excretion of carbon dioxide. In other words, we exhale the carbon dioxide. Remember, if we go back up here, that carbon dioxide combines with water in the body to form carbonic acid. So when we exhale carbon dioxide, that means it cannot combine with water to make this acid. So that's one way of getting rid of acid. Get rid of the CO2 that's going to produce part of it. Okay. Third is renal excretion of hydrogen ions. In other words, your kidneys can excrete or get rid of the hydrogen ions, the acid, in urine. So chemical buffer systems. And again, that's what the lab activity for this chapter is about. You find these chemical buffers in all body fluids. They're based on chemicals that will combine either with an excess acid or an excess base. So buffers are defined as substances that stabilize pH of a solution, despite extra acid or extra base entering that system. So more specifically, chemical components of a buffer combine with strong acids to convert them into weak acids, or they can combine with a strong base and convert them to a weak base. These reactions help to minimize pH changes in body fluids. And there are three important buffer systems in our body. It's the bicarbonate buffer system, which is the main one. Then there's the phosphate buffer system, and the third one is called the protein buffer system. So in the bicarbonate buffer system, which is present in both intracellular and extracellular fluid, the bicarbonate ion acts as a weak base And carbonic acid, its conjugate, is the weak acid. So buffers are made with a weak acid and its conjugate base, or it can be a weak base and its conjugate acid. Again, the idea of the conjugate is that's HCO3 negative. If I add another hydrogen that's positive to it, I would get H2CO3. So if this is a base and I add a hydrogen ion, proton's another word for it. If I take this conjugate base and add a hydrogen ion to it, I get this, the conjugate acid. Or look at it from the other direction. If I start with this conjugate acid and it gives off the hydrogen ion, then what's left behind is the conjugate base. So acids and bases, there are conjugate pairs. The base is missing a hydrogen ion, the acid has the hydrogen ion. So here we see a hydrogen ion, and bicarbonate, which is going to act as the base, it's going to accept or take in the hydrogen ion and give us the carbonic acid, which is the conjugate acid. And here, if we have our conjugate acid, it will give off a hydrogen ion and leave us with our conjugate base. Although this reaction releases bicarbonate, it is the increase of the hydrogen ions that minimizes the shift toward a more alkaline pH. All right. Again, the lab activity should be modeling this exact thing, and they're going to use color changing indicators that show you what the pH is, that let you see if the pH has gone above 7 or below 7. All right, the phosphate buffer system, also present in both intra and extracellular fluids. It's particularly important in controlling hydrogen ion concentration in intracellular fluid and in the kidney, the renal tubular fluid, and urine. It has two phosphate ions, which are called dihydrogen phosphate and monohydrogen phosphate. And the monohydrogen phosphate can accept a hydrogen ion to form the dihydrogen phosphate, or the dihydrogen phosphate can give off a hydrogen ion and become the monohydrogen phosphate. So when you add a hydrogen ion to something, that is the conjugate base, and this will be the conjugate acid. Here's the conjugate acid. It can give off the hydrogen ion and leave the conjugate base. Then there's the protein buffer system. Proteins, as I hope you remember, have a carboxyl group, a carboxylic acid, and that's why proteins are made of things called amino acids. This is the acid part. The amino part is the NH2 group. Well, the NH2 can combine with a hydrogen ion to form NH3+. So we have a conjugate base. We add the proton, I keep calling it that, I'm sorry, hydrogen ion. It's the same thing. We add a hydrogen ion to it and we get this protonated, this NH3+. This is the conjugate acid. Up here, this is the conjugate acid, and it can give off the hydrogen ion and leave behind the conjugate base. So because amino acids, which are the building blocks of proteins, have both the carboxyl group on one end and the amino group on the other, they can act as both an acid and a base, and that allows them to work as a buffer, because a buffer can combine with excess hydrogen ions to raise pH, or they can give off hydrogen ions to lower pH. And by being able to do both, they're able to stabilize or regulate pH. Okay, well, I've been talking a little too long here, I'm sorry. They're just talking here about where these tend to happen a little more than we need to. All right, so respiratory excretion of carbon dioxide. As I have said, if you exhale the carbon dioxide, you can't form the carbonic acid. But this This is relatively slow compared to the buffers. So buffers are your first line of defense against changes in pH in body fluids. Now, let me see, where do we talk about this? Back in chapter 19, we talked about the factors that affect breathing. So one way that your respiratory center of your brainstem regulates breathing is by monitoring pH. Now, since carbon dioxide and water form carbonic acid, which leads to hydrogen ions, which lowers pH, those respiratory centers will recognize that lowered pH and decide that it's because there's too much CO2. And it will cause you to breathe deeper and faster to get rid of that CO2 so that the carbon dioxide cannot lead to the formation of the hydrogen ions. The funny thing is, though, your body could be acidic due to something else, like ketosis. And so you might see a patient who's breathing rapidly, and it's because they're in ketosis, but all the brainstem knows is there's too much hydrogen. And so it will cause them to breathe faster and deeper to try to get rid of CO2. That's why we don't just look at, we look at several factors to determine what's going on. We would look for ketones. We would look for breathing rate. And we should have covered terms such as respiratory acidosis, respiratory alkalosis, and I'm having a hard time remembering if we actually covered that or not, and we should have. Anyway, that's what this relates to. If cells increase production of carbon dioxide, you make more carbonic acid, that makes more hydrogen ions, that stimulates the respiratory center. It's that pH, so the rate and depth of breathing will increase, and you'll get rid of more CO2. But that can be a sign of acidosis from another source. Let's see, do they talk about those terms right here? No, they don't. I need to go back and make sure I covered that. If you're still with me and you know that we did not talk about those terms, let me know. All right, renal excretion of hydrogen ions is the third and slowest way of getting rid of hydrogen to bring pH back up to normal. A lot of times this is going to be due to a high protein intake. So you'll produce more amino acids. That will lead to producing more sulfuric and phosphoric acid. And again, the kidney will excrete the hydrogen ions. You'll have acidic urine. Here's another conjugate pair. NH3 is ammonia. It can accept hydrogen ions to form NH4+, which is called ammonium. There's the word, ammonium. And ammonium is an ion. Ammonia is a weak base. It can accept hydrogen ions and form ammonium. And this is another thing that is excreted in urine, although it's not the main way. Here's where they talk about the time course. I've already alluded to that. Bicarbonate, or the buffers, work very quickly. They're the first line of defense. The second line is the CO2 excretion through respiratory means and the renal mechanisms. Okay, I believe that is it for this section.